So, do this. Yes, I think most of you were here last week, but for those of you who weren't, I'm Coleman Kane. We were just talking at the beginning of class about some of the cybersecurity work that my team does at GE. So I work for GE Aviation. Last week, we kind of did an intro to the class, talked about what the tentative schedule will be. Of course, it's always subject to change. Some of you who were in the cloud class last semester saw some of that. For instance, I might move some of the dynamic analysis stuff, which we'll talk about setting up labs today. I may bring some of that stuff earlier on in the class. But anyway, today we're going to pick up where the last lecture left off in talking about VirtualBox, actually setting up labs and kind of doing a crash course of looking at some of the features that it provides that are more valuable to malware analysis and kind of security research. So I'll go through these slides. I'll stop midway through, do a little bit of a demo for you. So I have a few of the VMs that we discussed last week, or not last week, on Tuesday. I have some of those brought up, and we can mess with some of it. So give you a little bit deeper discussion about VirtualBox. It's really an Oracle-owned project, but it's got a big community built around it. As I mentioned in the previous class, I know a lot of you may be familiar with VMware because it's offered, I believe, through the university download site or something. One of the nice things I like about VirtualBox is, or I should say, the 5 things I think are really great right here. But one of the big things is just an open source project, so it's actually GPL software, like a lot of the Linux kernel and a lot of the Linux tools are. Let's go ahead and sit down. That means that you have access to the source code. It also means that you have very minimal usage restrictions. So you can use it here. You can build a business around it if you want. You can use it at work in whatever job you go to. You can edit the source code, that type of stuff. So a lot more freedom, in my opinion, and a lot more transparency to it than the VMware product, which also is very good and is also very efficient. And I'm not going to downplay it at all. Just from a kind of academic and research perspective, the lack of visibility into the product does make it a little bit less attractive. So the other nice thing that I like about this one, and I know VMware is coming along with it, is a command line interface. So there's a nice UI for VirtualBox. There's also a powerful command line interface that allows you to do everything that's in the UI, plus a whole bunch of other features as well. So outside of that, I've gotten it to work on all the systems that I listed up there. So I recommend you use it just because I'm going to be using it for a lot of the demos and examples in the class. And also I'll be able to answer questions about this particular project, not so much VMware. So here again are some links. I will say the Blackboard site did get created. So this weekend I'll be working on trying to get this information that I put together on Tuesday and today linked on Blackboard so that you'll be able to use that. So all this stuff will be accessible there, but here's links for accessing it. I have found there's a lot of features in VirtualBox. The ones that I find most valuable for dealing with malware analysis labs are the 6 that I listed up here. So if you're reading the documentation, want to read ahead, those are the ones that I'd say focus on. I will go over a lot of these in class as well, so you'll have video of messing around with this stuff to go from as well. One of the big things is that these all help you, messing with the configuration for these features all help you put together a really nice malware lab. One of the things that we'll get into is some of the advanced features is it allows you to provide an environment that gives you a lot of flexibility, almost like a full system that you have dedicated to malware analysis, but it gives you a lot of features that allow you to protect your own system, so like my laptop here, and also the UC network and everything from, say, accidental malware escape or whatever you want to call it. So we'll definitely talk about how to keep your VMs safe from that type of stuff. So the first thing is getting a virtual machine. So you have VirtualBox lets you create the fake hardware. Those of you who were in the cloud class got to experiment with some of that in Amazon. The next one is there's kind of 3 primary ways to get a virtual machine set up. And we'll talk through the top 2 are the ones that I typically use. The bottom one, I'll make sure that there's some documentation referencing it, but we don't tend to see too many things distributed as disk images anymore, which means that you don't necessarily have to worry about it, but it's up here because I found it on some documentation site at one point, and I felt it was important to include. You know, the method we'll use is going to vary depending on how the media is provided to all of us. So the most familiar one for many of you who had to, say, put together a system or who have maybe worked in you know, IT job or something like that is your traditional install from installation media. So I do have some links to you know, new Linux distributions up here that are really popular. So if you haven't, say, used Linux, here's a good opportunity to get started. You can also get the Windows 10 images. You can download the ISO from DreamSpark. What I have found is that if you are trying to download it, you do need like a Windows or Mac OS system to download it. At least last time I tried DreamSpark, it would only give me the download if I was using a Mac OS or Windows system to download it. The download ends up providing you with an archive that in the end contains an ISO image, which is your CD image that you would normally give to any CD burning software that you wanted to. I kind of started demoing that installation in the last lecture as well. So that's probably what I'll recommend is trying to install the Windows version. I have some steps documented, so these are the steps that I was starting to take on Tuesday. Of course, it takes about 20 minutes, I think, to install the whole operating system if you have a decently fast VM. We'll get over here. There's a handful of notes on installing it that you'll also have to keep in mind, so just some gotchas. One of the big ones that I'll say up here, and this is a consideration you want to make sure that you keep in mind for any Linux OSs or any other versions of Windows that you install, is that when you're going through the installation, it typically asks you, do you want to like have automatic updates, or do you want to automatically look for updates, or do you want to send information back to the operating system provider, like do you want to send bug reports to Ubuntu, or do you want to send usage information back to Microsoft and stuff like that. Any of those options that tell you to turn on telemetry data, which is what that's the fancy word for what all that stuff is called, or bug report information, all that, you probably want to turn those things off, mainly because if you are analyzing malware in your malware lab, you're also analyzing the network traffic that the malware is trying to do. If you have your operating system trying to reach out and do things over the network, you're basically going to have a whole bunch of background noise. It's not impossible to eliminate from there. It's just an extra step or extra mess that you have to clean up every time that you're trying to analyze a sample. So installation gives you an opportunity to turn all those things off. So just keep that in mind whenever you're doing installation as well. I will also try and scrape together some documentation on closing those things on an already installed system as well, which might be helpful to you in the future. So I just don't have it for anything newer than Windows XP right now. So before I jump into the OVA import, I'll just kind of go here. You know, kind of what I'm talking about with this is, and this one's a really great example. Yeah, but I'll go here and I'll just do a new one for Ubuntu. So, you know, I'll say like, you know, Ubuntu test like 2 or whatever. I have no idea what version. One of the nice things about VirtualBox, and this might not have been clear when we were doing the install yesterday or on Tuesday, is that you start typing in the name there. VirtualBox automatically tries to figure out what you're trying to do. So it automatically figured out that I was trying to set up a Ubuntu VM and Linux VM. So if you're naming things and you start putting in these operating system names that you're going to use, VirtualBox is nice about auto-populating, saves you some time. One thing I will say is that if you do expand this list, and there's a lot more options here than there are for the Windows installation that I showed you on Tuesday, you'll notice that every single one of these things has a 64-bit or a 32-bit option. For the most part, unless said otherwise, I would recommend installing the 64-bit operating system, mainly because it supports, for the most part, all the 32-bit tools. So if you're dealing with 32-bit executables, stuff like that, it supports those things, but also because there's not any real resource savings you get from installing a 32-bit OS. And one of the complications you do run into is that you run into compatibility issues. So it's very likely that if you install a 32-bit OS, you'll go on the internet, find a tool that's supposed to be very useful at analyzing malware, try and get it installed on there, and it won't work. So stick with the 64-bit OSs. I've found that that just seems to be the most successful approach as well. So we'll go through this. I'll just pick some random things. You're picking hard drive size. The nice thing about this, and this is another thing that's highlighted by walking through this setup today versus the Windows 10 setup I did before, is that this thing actually has default or minimum or maybe average profiles for each one of these. So when I did Windows 10, it automatically set this up at 2 gigabytes instead of 1 gigabyte of RAM. This time it's picking 1 gigabyte of RAM, and it also picked a lot less hard drive space. It picked 8 gigs of hard drive space instead of 32, I think was what it set up automatically. So it's got hard-coded in it a bunch of profiles for the different operating systems that you can set up. So, but I just walked through about 4 different pages, and then I can create it. Always use the VDI image, dynamically allocated, create, and then I'll go ahead and create it. So now you have an empty system, just like what we did before. So then what I'm going to do is I'm going to, if you right-click on any of these, you get a nice window that basically has like these buttons plus some other menu options. So I just did the exact same thing if I would have selected this and clicked the settings button up here. I'll go here to the storage section, which is where your hard drive or your VDI is located, but also where the CD is to install. And what I'm going to do is I'm going to choose a file, and I think I have this right here. So that's my Ubuntu image. I can expand this if you want to see it, but it basically says that I have that right there. So then I've now done the same equivalent in software to inserting the CD into my laptop CD drive. So then if I start it, it should boot. And one of the big reasons I'm doing this is, number one, it's extremely quick. So this was a very quick, took me about, I don't know, maybe about like 5 minutes or so right here to go through from I want a new VM to starting to boot off the CD drive for Ubuntu. So I'm not going to install Ubuntu on here because I don't know if you can see it, but I already have about 3 or 4 different Ubuntu VMs. But I will let it go and run in the background. One of the other things that's nice is that, and I'll just show kind of a demo of it. This thing's going to pop up, and now it's going to allow me to try it or install it. So I can click try it, and it'll just allow me to run it. What it's doing here is it actually has a operating system installed on the CD image that you can run and interact with and use it as if you were, a normal user. So it's what they call live CD. A lot of the toolbox systems that we're going to use also offer a live CD mode as well. So if you wanted to, on say your Windows laptop or something, you wanted to have a image that you booted off of to run a certain toolkit for analyzing malware, for doing pen testing or something like that, they allow you to do that without having to destroy or resize your hard drive partitions. So that's kind of what this is. Now, one of the other nice things that VirtualBox offers is that if I want to, I can actually, so I can close it and it gives me an option here where I can save the machine state, or I can send the shutdown signal, or I can power off the machine. And the difference between sending the shutdown signal and power offing the machine is shutdown signal is pushing the power button, which is typically software power down, so it tells the system go into a graceful shutdown. And then, of course, power off the machine is popping out the battery, pulling out the plug type of thing. But the other one that's nice here is saving the machine state. And that one's really helpful because what it allows us to do is this system was running right now, and so it had a whole memory state in place and everything like that. So I could have opened up a bunch of applications. If I save the state, what it does is it actually writes all that memory to disk in a special location that's connected to the system that I have here. And it allows me to resume this at any time. So it's almost like the suspend feature that exists on your laptop or whatever, where you can close the lid and then it'll go to sleep. It's like a super sleep version of that, I guess is the best way to put it. So it's actually all implemented at the VM layer, so the underlying operating system doesn't need to support safe sleep or anything like that, like the operating system installed on your laptop does. It also means that you can have a whole bunch of different running versions of different VMs where you get partway through using it, and then you just save the state. So you don't have to worry about, say, losing your information or losing your place on what you were doing. It's a cool way to do like workspace management, and if you work on a lot of like malware analysis projects and things like that, you'll find that it's very helpful to you. So I figured I'd demonstrate the option right there. The other thing that's nice too is that you write the memory to disk. You no longer have it taking up memory. So you can have like 20 VMs in the save state like I have them now. You can have like 20 different virtual machines in that state, and they aren't occupying any like extra RAM or anything like that, or any extra CPU resources. So I can even close VirtualBox altogether and reboot my laptop. And then if I bring VirtualBox back up, that's still in the save state. And then if I start it again, it just resumes it by loading the RAM image that it saved to disk back into memory, and then starting the CPU at the next instruction. So it's very helpful. So I'm going to shut this down again because the next example we'll go to is going to be for a different method of import. So the easiest method, so that was pretty easy to do the install that way, but you still have to go through a normal system install. An even easier approach is to get what they call an, I forget what OVA stands for, but it's basically a VirtualBox appliance, what they call a VirtualBox appliance. So rather than just being a image of the files that are supposed to be on disk, it's actually that, plus the configuration information, plus any system state if there was any saved. So in this case, I have, sorry about that. I don't have, maybe it's in downloads. There we go. So I have some OVA files that are in downloads that I've pulled down from somewhere. So just check this out. So what I can do is basically go up here to the file menu, and I can do an import appliance, and then I can pick the appliance. I also have this one, which is a image, but I'll go to downloads, and so I have these four different images. So I can actually pull any one of these in, and these are actually contained already installed operating system images. Oh, or I can't. Oh, I know why. This one's probably one that the download didn't complete. I'll grab this one instead. Yeah, there we go. So if they're very large, they're, I think, each of these ones that I'm trying to load right now are about 3 gigs in size. So if the download canceled midway through or something like that, it's going to give you very ambiguous error because it doesn't know what happened. So this approach basically allows you to load the image and you get to see what the configuration was in the virtual machine as it was put together by the original author. So somebody went and created a new VM, called it Kali Linux 2016.2. Then they installed Linux on it. Then they installed a whole bunch of extra tools that are supposed to be for security vulnerability assessment and stuff like that. They called the whole thing Kali. And they actually give you some information where to go, who the vendor is, all that stuff, right? So they have a whole bunch of options in here for kind of describing who the author of the image was. They tell you what type of operating system it is, how many CPUs they configured it with. You can actually change these things if you want during import. So this gives you a little bit of flexibility to import something and you actually change what the settings were from what was originally given to you. All you need to do is double click on each one of these things. But I'm going to leave everything pretty much the same because the people who put it together probably had a reason for choosing this much RAM or this many CPUs, etc., or this specific sound card. So basically what I did was I ran that import task from the file menu. It gave me a file browser that allowed me to find the OVA files. And now it'll take a little while to import, so I'm not going to sit here and wait for the progress bar to count down. But after this is done, it's going to have a new VM that's imported right here that I'll be able to boot off of, just like I received a full, fully installed computer from a, from Dell or something like that. So. But yeah, these 5 steps right here are basically what I did. And then, so here's some sources for OVA images. I think I actually have some of this repeated later on in the slide deck too. But one of the really neat ones here that I've found has been Microsoft actually offers a version of, a website where you can download development versions of Windows with various versions of Internet Explorer installed on them. So if we ever work with any malware that's embedded in like a web page JavaScript or something like that, we have a whole bunch of different Internet Explorer versions to work with. So I'll go and jump to that site really quick. Oh yeah, that's right. It's going to load up. It's going to load up Firefox because for some reason I left that as my default browser. So give it a moment. No, there it is. So that works. There we go. So I can go to this Microsoft developer site. So one of the cool things here, and that any one of you can do this, so in addition to the Windows 10 image that you can get that has like all of UC's, default or desired stuff installed on it, you can go here and you have a bunch of different options for different versions of Windows that you can get. So there's Windows 7, which is a really old version of Windows. There's Windows 8.1. That has IE 11 on it. So in each one of these, they offer you the version of Internet Explorer, or I should say the version of a Microsoft web browser that was available on there, plus all of the successive versions. Additionally, Microsoft Edge, which is like the replacement for Microsoft Internet Explorer. So it's I can't remember how long ago. At some point, when Microsoft decided that their Internet Explorer package had a huge amount of legacy code in it that was relatively difficult to maintain inside Microsoft because the Internet Explorer browser dates back to the late 90s, I guess. A lot of the vulnerabilities that were observed in Internet Explorer, especially a lot of the ones that kept cropping up and cropping up and cropping up, were rooted in code that somebody wrote, 20 years ago that no one can remember how it's supposed to work. or why it does certain things. But when someone goes in there to try and make it not do the vulnerable things, something that it does functionally well also stopped working. So they had those types of problems. And, I'm certain none of you have ever run into code like that in the past. They decided to undertake a project to rewrite, basically write a new web browser from scratch, and that thing's called Microsoft Edge. So that's what you'll get on a lot of your Windows 10 systems. Because of that, it's different code base. That means that exploits that are written, malware written by people that are targeting different web browsers, may not work in Microsoft Edge, but may work in, say, Internet Explorer 9. So that's the reason why they offer a lot of this stuff. Likewise, another big reason too is that when you're writing web applications, so from the developer perspective, Microsoft is offering you a variety of different platforms that you can reasonably expect visitors to your website to possibly be using, so that you can maximize the compatibility and user experience of all of them. So if I picked one of them, like this one, then I could pick a platform, and they have a whole bunch of different offerings here, but one of the cool things is they did bother to include VirtualBox, and then if I want to, I can just download it, and then there you go. It goes and starts downloading, and that's right here. So I can download any one of those myself, and then I can use the exact same sequence of steps that I have in the slides in order to get them imported. After they're imported, you can do any of the typical system management tasks you want to, including like increasing the hard drive space or changing the memory or CPU configuration and all of that. So that's that. The other thing that's nice, and this might come in handy later on as you're working with different, working with malware and stuff like that, or working on installing multiple tools onto your malware lab, is that it might become valuable for you to, say, export, an OVA image. So, for instance, if I was to go in here and I'll just pick on this Windows 10 VM, right? So let me see the networking. So this thing is set up so that it can use the network that my computer has to try and get out to the internet. So I'll start up the Windows 10 VM right here. And it should boot up relatively quickly. Although we'll see if I remember the username and password that I entered in here. And if not, that's okay. I can do the same type of demonstration with one of these other things. Here, I'll try this one. So, whoops. So this one, I'll just grab the Ubuntu one because it's going to take a little while for that to boot up. So this Ubuntu test. So if I wanted to go and install a bunch of stuff on there, I actually ran it. Let's see. I can basically choose like export, and I can choose one of these to export. So like this one. I can't do a saved one. So good to know. I can't do a saved image, but I can do this Kali one instead, or let's do this one. So this is, I installed Ubuntu, and then I installed the Zen hypervisor on Ubuntu as well. So I installed a whole bunch of software in addition to Ubuntu. I can export that one. It's shut down and everything like that. So what you do is you just get to pick it from the list. It automatically selects the one that you have selected out here. But if I really wanted to, I could pick one of the other ones. Then I do like that. You get to tell it where you want to save it. So I'm just going to save it to documents. That seems to be the common one. What I will say is that this allows you to create a manifest file so that you can if you want to import it into another system, if there happens to be an error, or for instance, if you host it on a website and then someone comes along and tries to compromise it or whatever, there you can have a manifest file that tracks all the hashes and stuff like that, so that people can be, verify that what they're importing is the actual software that you're trying to distribute to them. And then finally, it allows you to pick a format. I always pick this one, so just remember, use the 1.0 format. If you hover over these, it tells you more about them. This one has like the fun word experimental format. Experimental formats can be interesting, but they can also be a headache, especially when you're trying to actually get something done like your homework. So I recommend the OVF 1.0, which doesn't have the experimental name in it, and therefore is probably more reliable for you, so you won't be fighting some weird obscure error at 10 p.m. at night when you're trying to get your project turned in. And then this allows you to fill in a whole bunch of that distributor information. So if I'm done with that, I go to export, and then this thing's going to go and do the same, basically, converse operation that I had the progress bar doing earlier, which this one's going to go and export it into an OVA file, the one I selected on the first window. So I'll let that run in the background. You can see Windows is updating. The other thing that's nice, and this kind of highlights earlier on Tuesday, I mentioned you may want to have a laptop that has sufficient RAM to host multiple VMs at once. You want to be cognizant of what RAM configuration you pick. So I've got a couple of different operations going on here at once while I'm trying to teach the lecture, and I haven't hit the resource limits on my system yet. But what I just demoed for you is basically these steps for the OVA export. Like I said, that may be very helpful later on if you're trying to set up, say, lab environments to work on. So, especially, for instance, if we do end up having like group projects or something like that, a way to share your labs with each other. So I demoed the state saving earlier. If you try to close the VM while it's running, it gives you the option to power it off or send the power off signal or save the virtual machine state. Snapshots are actually an extra feature of VirtualBox, and VirtualBox isn't the only thing that has this concept, but it's a very helpful feature that we'll probably use a lot. And what it does is it takes that save state, so it takes the configuration, the runtime state, or whatever the RAM contents were, and the disk state, and then it provides a way for you to save all of those in what it calls a snapshot, but basically keeps a record of what they were at one point in time. So for instance, let me go back here. There we go. So I'm going to get back to, I'll move this out of the way. I'm going to go back to, I'm actually going to cancel this because that is going to lock up my system. So I'll get that to cancel. But I can go back to one of these and let's see. Let me give this a second. There it goes. So I can go to one of these like this one, which is the one I was using before, the Ubuntu test that I saved. If I want to, I can, oh no, it's up here now. So I can select it, and then I go up here to the snapshot section. This actually allows me to, keep track of my snapshot. So I can actually take a snapshot of the image at multiple points in time. So for instance, I'll just call this one first, and then I can start this running again. When I start this running again, an important way to look at this is that first is a picture in time of the system. So it's a record of what the system configuration was, what was in memory, and what was on disk at a certain point in time, and also what was in the VirtualBox configuration. when I run it again, when I start this thing up again, it's always going to start running from the current state up here. So the state that I marked as first, that never changes. But as soon as I click start and the CPU starts ticking, memory starts getting modified because Windows is always doing random things behind the scenes and everything like that. So after this finishes loading, the image is actually going to differ from the snapshot that I marked as first. What I'll be able to do then is I'll be able to go through and work on, say, open a web browser or install more software, anything like that. One thing that you may or may not have noticed is that just now, where it says current state, actually added this word changed in parentheses to it. So that's a good indication that allows you to see when the current state actually contains a different system state than the last saved state. So that's an indication to you that if you were to destroy the current state or replace it with an older state, if you were to revert back to an earlier snapshot, then you would lose then you could potentially lose something. So VirtualBox actually analyzes the current VM state and also what you have saved to let you know if the previous saved state actually has anything of value in it. So for instance, what I might do then is I might load up Firefox and then also resize the desktop a bit or something. So I'll do that. I think Firefox is loading. So I'll also load up a terminal. Yeah, there it goes. So one thing to keep in mind, this right here is your disk, and you can see that it has a little light next to it. That right now it's green because there's a whole bunch of activity going on. So when it's trying to do something, that pops up like that. And then there's this thing. So there you go. Firefox is doing a whole bunch of stuff. If you remember, Firefox took a really long time, even on my native system, to start up when I accidentally clicked on that link to bring up Firefox. So don't take the slowness of Firefox loading as indicative of the speed of the VM. As you can see, now that it's loaded and everything's resident in memory, it's actually pretty responsive. So, what I might do is I might close this, and then I might shut this down and save the machine state again. So the current state is still changed up there. So then what I can do, if I want to, is I can take another snapshot of this current state and I can say something like Firefox loaded. And so now I have the first one, like first boot, and then I have Firefox loaded. And then if I start again with this, you can see that current state no longer has the word change next to it, which means the current state and then the parent of current state in this hierarchy list are the same. So I can start it again, and then I can, and then I can do something else. So for instance, I can load up a spreadsheet application or something. So I'll do that, and then I'll save it again once more. But what you can see that I'm doing here is I'm walking through a sequence of steps. And every step along the way that I'm doing anything significant, or in this case, I'm experimenting with loading a varying sequence of programs. So if I'm trying to analyze a piece of malware or something like that, I might load, or I will load, say, different components of that malware if it's if it's got multiple components to it. I may load different components of it, and I can use the snapshot feature to give myself the ability to revert back to, say, a clean state, but without having to wipe everything out. So now that is set up, and I can save the machine state now. And then the current state is now changed. And so if I wanted to create another snapshot, I can say, like that. So now I have a whole bunch of different states that I can revert to. And if I want to, let's see. I can go back to a previous state. So for instance, this one, let's see what happens if I do this. If I do this, what I've now done is I've gone back to the state, the step before the previous step. So I went back 2 steps. So I went back 2 steps. So I went back over the last step that I went. But that step that I just did is actually still present there, and it's changed the hierarchy for that. So that's really helpful as well, because that means that if I want to go back and say try something new like 10 steps ago, I can do that with this feature without having to throw away all the other experiments I was doing. So as you can see, I can gradually build out this research project almost. If I'm trying to experiment with, say, different features of the malware, or trying to experiment with maybe the malware running in different Windows configurations, with different programs running, or with different settings in the internet options and things like that. So, you know, if I want to, I can also do this. I can revert back to that. And so that structure kind of returns it back to more or less the organizational structure I had before, right? I can also, if I want to, use the sheep icon, which is a really nicely chosen icon. I can use that to create a whole new virtual machine that's based upon this particular snapshot. So if I want a brand new virtual machine that's derived, that basically is Ubuntu with Firefox and LibreOffice loaded on it, or whatever installed on it at that point, I can do that, and we'll create a brand new virtual machine that shows up over here in this bar. So it's another feature that it has, and I'd say experiment with the snapshots a bunch. That'll help you learn how to become proficient with them, so you can use it to try and guide, or I should say, you can use it to try and assist you in doing malware analysis without being destructive to the system. So one of the things I will say is that, and that's kind of highlighted in this paragraph here, but I'll go into a bit more detail, is that you're going to be dealing with software that's designed to be dropped onto a system. It's designed to hide itself. It's designed to embed itself in many different areas of the system, possibly, so install itself persistently into multiple locations, or add some redundancy for itself. It may be designed to destroy the system you're trying to run it on, things like that. Because of all those, possible problems, and just like, say, using GitHub for developing a software project, or for continuous integration of a software deployment, VirtualBox allows you to be able to take some of those same safety precautions to your malware analysis. So it allows you to have a lot less risk when you're trying to poke a malware sample, when you're trying to mess with it and say, hey, I wonder what happens if I do a certain thing. So becoming really proficient at this and figuring out how that hierarchy works and figuring out all the different features that you have is an extremely valuable tool. So the other thing that VirtualBox offers, and I haven't really showed you yet, is it allows you to configure at least 4 different network interfaces. Actually, if you modify, I can't remember if the UI offers this, but I believe the command line still allows you to add new network cards beyond the 4 that are present in the user interface. So, excuse me. So you can actually set up some pretty complex network hierarchies with it as well. We probably won't go into too much detail with those, mainly because I do recognize that even we're all working off laptops, and laptops have their own kind of system limitations as far as how far you can push them beyond, say, 2 or 3 virtual machines. But that said, The ones that I do have in bold up here, so NAT, and then internal network and host-only networking, those three networking configurations that are offered in VirtualBox are probably the three that we'll spend our most of our time in. So if you go into Chapter 6 of VirtualBox's manual as well, it goes into detail for each one of these, but we can mess with some of them now. So let me see how the Windows VM is looking. Yeah, so let me see. Here we go. So what I have right now is, I'll show you one more very easy user interface thing too, is that if you hover over these things, it actually gives you some insight telling you what the different icons mean when they're colored different colors. So like I can hover over this, I think. Yeah, there you go. And it tells you about the hard drive networking. So this one actually tells you which network adapter, or I should say the current status of all the network adapters, including, you'll see it says NAT right there, telling you which one of the configurations that network adapter is using, and also whether the cable is in the connected or disconnected state, which is also something, because you don't have any physical cables, you have a little software program that pretends to be a network cable, and that software program ends up allowing you to emulate whether the cable is connected or not. So, and then also it supports emulating the audio as well. So what you just heard was the audio coming from Windows. So it's another benefit to it. So what I can do is if I right-click or double tap if I'm using a trackpad or whatever the Mac equivalent of it is, you can bring up a menu that allows you to choose some options. So I can go to the network settings through here. So rather than going using the settings panel here and navigating to it, I can actually just bring it up here and it automatically jumps to network. So this attachment is actually listed right here. So that selection, or I should say that bulleted list that I showed you on the slide, that's basically all the options here. So we'll go through these. Network address translation. I'm not going to go into huge detail how that works, but for the most part, how it will appear to you is that I've got my laptop connected to UC's Wi-Fi. So what's going to happen is any time that I want this virtual machine or any of my other virtual machines that are in NAT mode to access the internet, what they're basically going to do is they're going to ask my laptop to go to the internet for them, visit the page, send whatever packet they want on their behalf, and then it's going to translate that. So when it returns, or when it gets any information back, if it's part of a connection that's associated with this VM, my laptop, or I should say VirtualBox installed on my laptop, has some smart software in it that knows to route those packets back to the virtual machine. So the virtual machine itself, inside of there, Windows has no idea that it's running behind this translation layer, but the translation layer exists. The benefit to this for all of you is that your virtual machine can reach out to the internet. Your virtual machine can also reach out to your laptop. Your virtual machine can also reach out to any machine that's on your local network. But nothing that's out there on the internet or on your system or whatever can actually, or on your local network even, or even on your laptop, can initiate a network connection that tries to connect into your VirtualBox session. So just like if you have a NAT set up at home through like a DSL router or something like that, it works just the same way. So benefit to that is that, for instance, you saw this thing was popping up all those little notifications, right? So let's see. The notifications say updates were installed. So this allows me very easily to have Windows have internet access and everything like that. So that can be beneficial, for instance, if you're trying to work with a piece of malware that needs to be connected to its home, or is trying to download more malware samples from the internet and stuff like that. This is a very nice kind of almost safe mode to do it in, because just like any other virtual machine, unless I specifically grant access using this master VirtualBox interface, whatever happens inside of Windows 10 here stays inside of Windows 10, except it can communicate with the internet. So this is kind of as long as I don't worry about revealing my IP address location and some of that stuff, this is actually a really safe environment, to say allow, relatively safe environment to allow an adversary into, providing that, you don't worry about resources and that type of stuff. There are some more esoteric attacks. So some people have concerns about, say, whether all VMs are perfectly contained. There is some of that debate. I will say that for the purposes of this class and what we're going to be dealing with, we're not necessarily going to be worrying about other people coming into our systems. We're more going to be worrying about our own actions, whether they stay inside of those systems or not. So I can go to like google.com from here, and it can use Google, right? So another option, is if I'm totally, here we go. Come on. There we go, network settings. So another option that I might want to do is I could do bridged adapter. If I chose bridged adapter, it actually allows me to bridge it with my network card. So this has the same effect as if I was to have a network cable plugged into the wall, right? And a lot of times what you'll end up doing is you'll plug your laptop or desktop into that network cable if you don't have Wi-Fi. If you were to plug a switch into that network cable and then plug 3 laptops into that switch, more or less this is allowing you to have that same feature, but have it built into VirtualBox. So I could set it up so that, so the bridge adapter. So what this ends up doing is it ends up giving, or I should say allowing my adapter in here, the adapter in Windows, and I should actually, I'll go and do this, and I'll see what it does. You can see it just dropped the network connection. Depending on how well this works with wireless, so I'll say no. So what it did was it actually now is able to get an IP address from like UC's Wi-Fi, basically. So it's connecting to it as if it's another device on UC's Wi-Fi. There's definitely some issues with that and bridging it to the protocol that UC uses for that. So it's probably not going to work very well. So I'm going to go to the next one, because we won't use bridge mode too much. You may end up using it, say, at home or something on a home network. We'll go to internal network. And so what internal network allows you to do, and this one's very helpful, is you can give a bunch of these networks names. So like this one's, I just gave a network the name test0. What this allows you to do is it allows you to set up mini switches inside of your virtual machine. So for instance, if I give any one of these other virtual machines a network of test0, then it means that both those VMs will actually sit on the same network. This is where it comes in really handy if you do have a lot of if you do have a lot of CPUs. You can run many virtual machines on there and have these very complicated network layouts where you may have 5 or 6 different network segments that have, say, 5 hosts on them each. And you could have all those segments have like nice descriptive names. And then if you write those names on, say, the network diagram, you can also reflect them here using the internal network. The other benefit of this internal networking is that internal networking only operates within the software networking component of VirtualBox. So none of this internal networking traffic will actually be able to ever access the internet, or won't be visible on your local network or anything. So this is a good way to create a networked lab, so multiple virtual machines that are networked together, and they can talk to one another, but you feel reasonably safe that they aren't going to accidentally talk to and start attacking a network attached storage device that you have on your home network, or they're going to randomly start trying to attack like something on the UC network or anything like that. So, so I can try putting test 0 in there, and and start that one up. Oh, whoops. That's not what I want to do. Well. So a really common approach is to go in here and hard code the IP address settings. So for instance, I could go in here and I can say 192.168.3.12. And then also I can boot up Kali, and I can do the same thing. I could put it on the same subnet, and something, I can't remember what exactly I set it to, but I should be able to have these two talk to each other. I don't know if I can actually, to be fair, I don't know if there's something else I have to do in Windows as well to get it to work, but yeah, I don't know. So I can set up these networks. I don't know why this one's not connecting, but it could very well be that I messed up when I was typing the different networks. But the idea is that you can put together these like fake networks that are internal, that don't expose themselves even to the host. So even this, I can't use TCP dump or anything like that, or Wireshark to analyze the network traffic that's going to happen between these two if I actually get them connected. Yeah, and I'll try and mess with this a bit later. I'll bet that there's something else going on here that I need to sort out. And then finally, the last one is if I wanted to go with host-only adapter. And so with host-only adapter, what that allows you to do is, and in order to use it on a new VirtualBox system, you need to make sure that you configure the preferences for the whole VirtualBox management application. So you go here to network, and you go to host-only networks. You'll actually have to, you may have to manually add host-only networks. These work very similarly to the previous one I showed you. So to the internal network. The only difference is that in addition to it being an internal network that's accessible to VMs, it's also a network that is accessible to your laptop. And how it's accessible to your laptop is it creates a network interface. So in Linux, or I should say in any Unix, it's going to create a network interface that has this name. So when I was showing you this thing, preferences, network, I can actually create new network adapters here, and I can give them different names if I want. If I go here, I actually have access to it as if it were a network card. If I'm running VirtualBox in Windows, then what it ends up doing, and I'll jump into here for a moment just to show you, what it ends up doing is that if this Windows system that you're seeing right here was actually my laptop, you would actually see a VirtualBox interface in here that you can configure, just like any other network interface. So, but right now we're dealing with something that's inside here. So let me see. Come on. Sorry, my touchpad is a little bit difficult. So there's that. I'll see if I can so I can ping this thing. I don't exactly know what the difficulty is on being able to ping this, but let's see. Okay. So what I've just demonstrated there is that the Windows system is able to ping the virtual interface that I have here. If you remember, and some of you have probably run into this when you plug in or when you associate your Windows system to, say, the UC wireless for the first time and stuff like that, it asks you those weird questions about, please tell me if you would like other systems on the network to be able to discover your Windows machine and stuff like that. So if you remember, that popped up when I put this in bridge mode. And I just instinctively said, no, I don't want you to do all these unsafe things. Most likely what happened is it put a whole bunch of firewall controls in place that prevent me from being able to ping the Windows machine. But they don't prevent the Windows machine from being able to ping other things on that network. So what I can do, what I can try and do, is I can actually go back here. And this is one of the cool things about VirtualBox as well, is that I've been running Windows here, right? And just letting it work, and I'm sitting here changing all these things about its network configuration behind the scenes. So you can actually bounce between different network configurations and everything like that. So let's see, yeah. And so if you remember, I gave the Kali Linux the IP address of .11, and so it's actually able to talk to the Kali Linux on that little segmented network, on that test 0 internal network, but it's no longer able to talk to the laptop's IP address. So I've set up a IP address of .10 for my laptop, .11 for the Kali Linux distribution, and then .12 for this Windows system. So then what I can do, if I want to, is I can go through here, come on, and I can set this back to the host-only adapter with VBox Net 0, and then I can go to Kali, and I can do the exact same thing there, right? And then, if everything is working all right, it may take a moment, or maybe not. Let me double check. So one thing that might have happened is when I switch that, this might have, this is here, 12. Well, let's see what happened. So you'll see the IP address up there changed. So I need to just force it to this again, right? So there we go. There's that. And then this one also changed, so you can see it's no longer .3. Oops. Let me change that. There we go. So now, so I can ping .11, .10, and then I can ping myself. So I can ping all three of them. So what's happening down there behind the scenes is that this is actually running the network manager that comes with whatever version, whatever distribution of Linux is on here, and that's actually listening to DHCP requests. So one of the additional features, in addition to network address translation, NAT, and a whole bunch of complicated complex virtual networking options, VirtualBox also allows you to configure, if you so choose. Let's see, maybe this thing? No, not that. Might be here. So if I go here, so that's the host-only network that I'm looking at. So it actually allows you to enable a DHCP server on there as well. So that's a common thing that someone would typically want to install on one of the systems on an internal network that they're building, like on a lab network or something like that. Knowing ahead of time that that is a really common piece of infrastructure to deploy, and knowing that you have limited resources on your laptops and everything, the people who put together VirtualBox don't exactly want you to waste an entire CPU and VM on a DHCP server, so they actually built one into it. So actually, I could have all of my systems that are on that same VBox Net 0 host-only adapter. I could have them all set to basically auto-configure their IP address, and VirtualBox will handle that in the software that it has. So that's another very helpful just hint to throw out there as well. Let me go back here, and then So as I said, I went through a bunch of the different networking options really, really fast. This manual page, chapter 6 of their HTML manual, has a lot more detailed information, as well as how to change and tweak these settings from the command line. I'd recommend experimenting with the command line as well, and I think later on in class we'll probably touch on it a bit, at least with some like really common command line operations, because it becomes something very useful for you if you want to automate a lot of the manual, like hunt and peck type of tasks that occur. So the other thing too that I'll just throw out there, and this is a little bit of a rehash from an earlier slide. OVA files, it's becoming a lot more common for people to not only deliver the pre-installed OS image, but also pre-configured ones. So I want Ubuntu, but I also want like these other 5 applications on it, because those 5 applications are really useful to a particular area of research or work or study or whatever. So you see that a lot, and security work is no different. So the 2 popular ones that, just in talking to a lot of my peers, a lot of people use is Kali, which is Linux distribution. It's distributed by Offensive Security, which is a security training consultancy company. Their stuff's available here. You can download an ISO image with a live CD, just like I showed you with the Ubuntu installation. you can also download an OVA image. And so basically a pre-installed system. Same with Remnix. Remnix is the same concept. The only difference is that the tool sets are different. So Remnix actually has a lot of tools that are very useful for doing malware analysis and reverse engineering tasks, but they don't have a whole bunch of tools that would have been useful for like pen testing and things like that. And then finally, VulnHub is a really popular site where people host pre-configured vulnerable system images. And so that's actually a really good demonstration of this packaging approach. Is systems that have had people come in and make small modifications to try and mimic what happens over the lifespan of a server or of a workstation or something like that. So if you go to that site, it's basically a really long archive. So it's almost like, it's like a GitHub for various people's ideas of vulnerable system images. And you can go on there, you can download an OVA in many cases of a pre-built system. And then you can also download walkthroughs on how to use different hacking tools in trying to attack that pre-installed system to try and demonstrate some concept or to try and demonstrate some special features in the tool that are only useful in certain situations and stuff like that. So definitely if you're interested in kind of more attack side of security research, that's a really great site to go to because it's got a lot of people's kind of collective wisdom built into it. And it kind of gives you something, gives you a view into an area of study that a lot of times is kind of off limits for many of you.
Is there any like OVAs that have like Remnix with malware like actually installed on there that like, you can straight analyze like problems that kind of were developed?
I don't know. I do know there are sites that do host that, and then they expect you to pull them into Remnix and basically have documentation on how to use Remnix to take apart a piece of malware. One of the things I didn't talk about that was on the earlier slide of features that I was going to show you is the shared folders feature that's in VirtualBox. And what I'll probably do is just tack that on to the beginning of like the next lecture and how to get stuff to analyze into your VMs and how to get files out of the VMs and how to execute commands on the VMs and stuff like that. But yeah, a lot of those tools are designed, I should say a lot of the sites exist and they expect you to use, say, one of these distributions to achieve a task. So, yep. Any other questions or comments? Cool. Well, we're right up on time this week, so